let's start your today's lecture. Do you remember what we have studied in our previous class? Let me share the screen. Do you remember what we have studied in our previous class? About plain concrete, the first generation of concrete. Then we have studied about reinforced concrete. And the third generation was fiber reinforced concrete. Then we have studied types of fibers. Historical background of fibers, all these things have been studied in our previous class. And also the mechanical properties of FRC. All these things have been studied in our previous lecture. Yesterday we have studied all these things. Do you know what is plain concrete? Can you answer me?
The concrete is pure concrete and it doesn't have steel inside it.
Wait. Rusman, can you repeat your...
I think it's a pure concrete. It doesn't have any steel inside it.
Yes, it's a pure concrete, doesn't have any steel inside it, so we can call it cement, sand, aggregates, plus water. It's a plain pure concrete. And the reinforced concrete, the only one thing that we are going to be add, that is cement, sand, aggregate, water, plus only one thing which is additional, that is steel. But in this third case, the only one thing which is additional, that is cement, sand, aggregate, water, steel. This is optional. Sometimes we use it and sometimes we don't use. It depends on our requirement. And fibers. Okay, there are two types of fibers available. Who will name them? Can you please tell me how many types of fibers available? There are two basic types of fibers are available. Mr. Mark.
Nature fibers and artificial.
Mr. For you. For you, can you hear me? Mr. Charlie, do you know how many types of fibers available?
Hello, can you hear me? Can you hear me?
Yes, please tell me, how many types of fibers available? Any one of you who will tell me how many types of fibers available?
I remember it's nature fibers and artificial fibers.
Yes, Bruce Wayne, you are right. There are two types of fibers available basically. The one is called natural fibers and another is called artificial fibers. Do you know what are the natural fibers? Any name? I have wrote so many names yesterday. Bruce Wayne, do you know? Do you remember? What are the natural fibers?
I remember. I forget how to call them, but I know what that mean. Eraser, like that. No eraser. That's what.
Oh, let me write the name.
Bamboo fibers.
Yes, Mr. Bill. Do you want to say something?
I can remember is the bamboo fibers.
Yeah.
From the bamboo, and some other plants I can't remember very clearly.
Another one is hair fiber. Please note down all these things. Bamboo fiber, hair fiber, and coconut fiber,
Coconut fibers.
asbestos fiber, asbestos fiber, etc. These are the natural fibers. Do you remember any name of artificial fiber? Mr. Dragon, do you remember?
Nylon fibers. Nylon fibers. Hello. Can you hear me?
Yes, I can hear you.
Nylon fibers.
Yes, nylon fiber and polypropylene.
I only remember this one.
Polypropylene. We call it polypropylene. Polypropylene. Remember the name. Nylon fiber, polypropylene fibers. These both are related to the plastic fibers. And steel fibers, glass fibers. All these are artificial fibers and etc. What are the mechanical properties of fiber reinforced concrete? There were three basic mechanical properties? Do you remember? Compressive strength, STS means splitting tensile strength. Let me write the name. And flexural strength. Okay, remember these names. We have discussed what is compressive strength, what is splitting tensile strength, what is flexural strength. All these things have been studied in our previous class. Okay. One more thing, FRC is why we prefer fiber reinforced concrete, because of its two things: its energy absorption capacity is strong and its toughness is strong. Okay, these two things are stronger in FRC, that's why we prefer to use fiber reinforced concrete. Do you have any question, any student? Mr. Jack, Bruce Wayne, Marcus, Queen, anyone have any question? No question, can we continue our lecture? Okay, let's begin. Let's move towards chapter number 3. If you have any question at any time, just raise your hand, ask me, I will repeat that topic or that point so that you can understand it. Chapter number 3, the title of chapter number 3 is Concrete Structure Design Basic Principles. Now we are moving towards the principles of designing. What are the principles, what are the rules and regulations of concrete structure design? The content of chapter number 3 are buildings, functions and purposes of the structures, structural types and their components, limitations of concrete, structural loads, importance of codes and clauses, types of loads, concept of factored load combination and strength reduction factor, calculation of building loads, 3 basic design philosophies. All these things will be studied in this chapter. This chapter is a little longer than the chapter number 1 and 2. So we will finish this chapter in 2 lectures. Okay, so let's continue it. The first topic, that is building. You can see a kind of structure in this picture. We usually call this type of structure as a building. What is the definition of the building? Building or edifice. The second name of building is edifice. Building is a structure with a roof and walls standing more or less permanently in one place. When roof and walls of any structure standing together, that structure will be called as building. It will have different purposes. We construct the buildings for different purposes, like for houses or factories, etc. Buildings come in a variety of sizes. Building will have different sizes, different shapes and their different functions. You are listening me from a building that name is, it's a university building, it's a campus. Some buildings are bank buildings, hospitals, shopping malls. All these are different functionalities of the building and have been adopted throughout history for a wide number of factors. Which factors? From building material available. Another one is to weather conditions, land prices, ground conditions, specific uses, and aesthetic reasons. These are the different factors which are being considered in a history. This is, if I am also talking about this picture, it's a block of tenements, apartments, and Brunsfield, Edinburgh, Scotland. It is located in Scotland. To better understand the term building, compare the list of non-building structures. You know the building structures, but do you know what are the non-building structures? Which structure is the non-building? Any one of you? Can you reply me? Which structure is the non-building structure? Bruce Van. Don't talk there, please. Concentrate on the lecture. When I am finished my lecture, then you can discuss with anybody. Okay? Do you know any non-building structure? Any name of any non-building structure? Mr. John. No one is replying. Okay. Let me
maybe bus station.
Fario have speaked. Fario, I didn't hear you clearly.
Yeah, the bus station.
Yes, Fario.
Yes, can you hear me?
Yeah, I can hear you.
Yeah, I mean bus station is a kind of non-building.
And any other?
And the carport.
Carports.
Yeah, carport.
Yes. We can say that carport is also a non-building structure. Let me write the definition of non-building structures. Let me write down the definition of non-building structures. What are actually the non-building structures? Non-building structures are those structures which are not continuously occupying by the human body. Those structures which are not continuously occupying by the human body, those structures are called non-building structures. Like for example, what are those structures? As for you mentioned that bus station, car porch, these are the structures which are not continuously occupying by a human body. Sometimes we use them and sometimes we don't use them. Like bridges, offshore structures, etc. Okay. After 10 minutes, the call will be disconnected and you have to request me again to join the call. Functions of structures. There are few functionalities of the structures. Structures need to be fulfill its functionality. It's for example, you have constructed a building for school, then it should be functionable throughout its life. For example, you have constructed a building for school and its life is 50 years, then for the whole 50 years that building should be functionable for school purpose. Similarly, the building must be stable and it must be durable. And most important, the economy is the most important factor. It must be economical. So to build means making use of solid materials to create a space that will fulfill a particular function. Which function? The particular functions. Those particular functions are enlisted here. The buildings as a structure must fulfill the following conditions. What are those conditions? Satisfy the need for which it was built. It should satisfy the need for which it was built. It must resist the loads coming to it. It must be stable. Must continue to fulfill its function means it must be durable. It must be durable. And it must be achieved with the minimum use of resources means economy. Buildings are constructed to serve a range of purposes. What are those purposes? For which purpose we usually construct our buildings? For shelter, to have a conductive place for work. Shelter means like carporch, etc. For schools, industries, and entertainment purposes, and all you can think of. Buildings are produced by the coordination of inputs of group of people, because a single man cannot construct a building. Obviously, a group of people, a good teamwork will be required for the building purpose. Under the provision of guide law called the building regulations. I don't know is there any guide law or any regulations available in is there any regulation available in Nanchang? Even when we are talking about Pakistan cities. For Islamabad, the regulation law or the building guidelines are available. You have to follow CDA. CDA is Capital Development Authority. Similarly, for another city like Peshawar, The development authority name is PDA. Peshawar Development Authority. Similarly, for Rawalpindi, it is RDA. For Lahore, it is LDA. And for Karachi, KDA. Similarly, these are the authorities which are, if you want to construct any building in these cities, you have to follow the guidelines which is provided by the specific development authority. For example, if you want to construct a building in the area of Islamabad, then you have to follow the guidelines which is provided in CDA. If you are not following the exact guidelines of CDA, then they will not allow you to construct any building in Islamabad. You have to follow the guidelines. So is there any guidelines or regulation laws available in Nanchang? It may be called as NDA, or I don't know the Chinese name. Any one of you, do you know the regulations related, similar regulations or similar guiding laws in Nanchang as we are following in Pakistan? No? Yes, Mr. Alex. Mr. Bill, is there any regulations available in Nanchang as we are following in Pakistan for different cities? It will be a kind of book and you have to follow that guidelines. If you know, then please mention the name so that your co-fellows may know about that. Okay, search for it. If you don't know, then search for it. Ask from any Chinese teacher that is there any guiding laws and regulations are available in China as we are following in Pakistan. Well, you may know about that. It's a quite simple slide. Structure types and their components. A building is broadly divided into two parts as we have explained it before. Substructure and superstructure. Substructure is the one which is beneath the natural surface level, and superstructure is one which is above the natural surface level. The portion of the building below the ground is a substructure, and the portion which is above it is the superstructure. So the component of the building can be broadly summarized as follows. These are the main components of the building: foundation, beams, columns, walls, floors, doors and windows, stairs, roof, services, etc. Understand? Please remember this thing. Substructure and superstructure. Substructure is that part of the building which is beneath natural surface level, NSL. Natural surface level, which is beneath the natural surface level. that structure is called a substructure, and which is above the natural surface level, that is called as superstructure. Remember these definitions. And it is also written here, from here to here you can see that the portion of the building below the ground is substructure, and the portion of the building which is above, that is called superstructure. This is the first part and this is the second part. Okay, and these are the main components of a building: foundation, beams, column, walls, floor, doors, windows, stairs, roof, services, etc. Let's continue the lecture. We have discussed this thing. The different components of structure are discussed, and different types of structures are already discussed. Now it's time for limitations of concrete or disadvantages of concrete. There are 8 reasons behind the limitations of concrete, and we will discuss all these 8 reasons one by one. Though concrete is one of the most widely used construction material, concrete is the most widely used construction material, there are a lot of disadvantages associated with it. What are those disadvantages? We will discuss all those one by one. Some of these disadvantages of concrete are modifying by adding admixtures. These advantages can be changed by adding admixtures or modifying the concrete structure and ingredients. Do you know what are the ingredients of the concrete? Cement, sand, aggregate, all these are the ingredients of the concrete. Still, there are lot of limitations associated with the concrete. Even though we can add admixtures, we can change the ingredients percentages, but still there will be some limitations of the concrete. What are those limitations? The major limitations are enlisted here. The first one is concrete is quasi-brittle material. As we have discussed yesterday, concrete is a brittle material. Number 2, it's have low tensile strength. It have low tensile strength. Concrete has low toughness. Concrete has low specific strength. Concrete always required form work, long curing time, and working with cracks demands strict quality control. All these are the limitations of concrete. Let's talk about them one by one. You know about that concrete is basically a brittle material. 3 major modes of failure of materials are brittle, quasi-brittle failure, and ductile failure. The typical failure of brittle and ductile failure are glass and mild steel. These are the examples of brittle. And for brittle failure, the example of brittle failure is glass, and for ductile failure, the example of ductile failure is mild steel. Brittle material fail once tensile strength is reached. When the tensile strength is reached to its maximum limit, then brittle materials will fail. It is sure. Unlike these materials, concrete exhibits a strain softening behavior. These materials are called quasi-brittle materials. Well, brittle and quasi-brittle materials like concrete allows very little deformation before failure. Why? Because it is brittle in nature. So concrete will allow very little deformation before it fails. Less the deformation, lesser will be the warnings. Because this deformation will gives you warning. So as much as the deformation is less, so warnings will also be less, and people will not easily evacuate from the building. This is the major disadvantages of plain concrete. That's why the second generation of concrete, that is called reinforced concrete, is required. For these reasons, concrete is used along with steel to take tension, and concrete itself take compression loads effectively. Thus, reinforced concrete, as I speak before, reinforced concrete is second generation concrete. And the third one, low tensile strength. Obviously, compression strength and tensile strength of concrete are not the same. In fact, see this line, we have already read this before. The tensile strength of plain concrete is 1/10 of the compressive strength. The tensile strength of plain concrete is 1/10 of its compressive strength. Tensile strength is 10 times lower than its compressive strength. That's why fibers and other polymers are introduced to the concrete to increase its tensile capacity. You can see this type of this is the polypropylene fiber. You can see in this picture, these fibers are polypropylene fibers. The name of these fibers are polypropylene fibers. It is made up of plastic. When fibers are available in the concrete and concrete fails, in case concrete fails, then these fibers will act as bridge phenomena. The bridging phenomena between the fibers will activated. Load, when concrete fails, concrete itself cannot take any more load because concrete is cracked, but the load will be taken by the fibers available inside the concrete. These fibers will act as a bridging phenomena. Concrete has low toughness. What does toughness means? Toughness, the simplest definition of toughness is it is the ability of a material to consume impact energy. See, do you know what is impact energy? Impact energy is a kind of energy which we apply in this direction, means the force applied in the form of jerks. That force is called impact energy. If I hit this board like in this direction, that force will be considered as impact energy, impact force. Impact force is a kind of force which is applied within 1 or 2 seconds on the body, and this force is suddenly removed. Such kind of force is considered as impact force. So, the ability of a material to consume the impact energy is called its toughness. And the second definition of toughness is it is the area under the load displacement curve. Uh, let me show you. You can open the board, which is mentioned over here. If the load displacement curve is this over here and this direction, it is load, and this direction it is displacement. And this, for example, this is the curve of load displacement. Then this area, you can see this shaded area will be considered as toughness. Toughness can be calculated. It's have a longest formula available. This area, the area under the load displacement curve, this area is called as toughness. You can calculate it. It have a longest formula available. When we require it, then I will provide a formula. So another limitation of concrete is that compared to steel, the concrete has significantly low toughness. The plain concrete will have low toughness. Toughness of concrete is only 1 to 2% of steel. Fiber reinforced concrete provide better toughness to the concrete. And the third one, the fourth limitation of concrete is concrete has low specific strength. The ratio of what is specific strength? Basically, the definition of specific strength is mentioned here. The ratio of strength to density is called specific strength. The ratio between strength to density is called specific strength. Specific strength of normal grade concrete is half that of steel. For example, the steel strength is, for example, 40 KSI. For example, the steel strength is 40 KSI, then the concrete will be of 20 KSI. It's just an example. So the strength of the concrete is the normal grade concrete will be a half of this steel. Specific strength is controlled by decreasing density and increasing strength. If you decrease the density and increase the strength, so specific strength will automatically increase. Lightweight concrete and high strength concrete mitigates these limitations of concrete. If you use lightweight concrete and high strength concrete, then we can override on this limitation. Formwork, obviously, for any concrete project we need a formwork. Fresh concrete is in the form of liquid. Formwork is required to mold it in a shape and to support its self-weight. Shuttering can be this type of shuttering. Can you see this type of shuttering? This is a formwork. This shuttering can be of different materials. What are those materials? Shuttering can be of plastic, steel, or wood. The formwork is expensive to install and procure. Installation requires intensive labor and time. That's why if you want to ride on this type of limitation, then what you need to do, we move towards precast and prefabrication technique to overcome these limitations of concrete. If you don't want to use the formwork, Then you have to construct the structural members as a precast and prefabrication. Precast and prefabrication is a technique which is used for that type of structures which we cannot construct on the site. We have to construct the structural element somewhere else, and then we will bring those structural elements to the site and combine them together. As you can see, this technique is used in bridges. Long curing time, obviously, concrete attains specific compressive strength in 28 days after casting and curing. As I have explained before, concrete obviously can attain different strengths: 7 days strength, 14 days, 28 days, but the specified compressive strength and 28 days. So you need to provide the curing for 28 days to get the specified compressive strength. Full strength development requires proper ambient temperature and controlled over a 1 month time. This is another disadvantage of concrete. Curing period is reduced by steam curing or microwave curing. If you provide steam curing or microwave curing or using admixtures, then you can minimize, you can overcome this time period. If you use steam curing, microwave curing, or using admixtures, then it may be the same specific compressive strength can be attained within 2 days, 3 days, 5 days. You don't need to wait for 28 days. Working with cracks, tension face of the concrete has a cover to protect the reinforcing steel bars. See on the board? For example, this is a beam. See, for example, this is a beam. This lower part is the part which is the cover of the steel. For example, the steel bars over here. These steel bars continuously in the whole beam. This lower part will be the cover. If you are reading, if this lower part is dismantled, we usually call this failure is spalling failure. If this lower part of the beam, this cover of the beam is dismantled or fail in case of spalling, then what will happen? Can you see these steel? These steel from the bottom of the beam, you will be able to see these steels. If you are weaving these steels from the bottom, it means these steels are exposed. These steels are exposed to the environment. If these steels are exposed to the environment, then what will happen? Rusting and corrosion of steel will occur. When rusting and corrosion of steel occurs, this beam will fail, this beam will collapse, and your structure will be failed. So this is the one more limitations of concrete. So read it over here. Tension face of the concrete has a cover to protect the reinforcing steel bars. If tensile stress at extreme fiber exceeds the tensile capacity of concrete, it cracks and lead to corrosion of steel. Can you see that? It will cause the corrosion. Normal reinforcement concrete is assumed to be cracked in service loads for design. To overcome this limitation of concrete, we have to move towards the third generation of concrete, and that is pre-stressed concrete is introduced. This is the third generation of concrete. And the last limitation, the name of the last limitation is demands strict quality control. Concrete demands strict quality control and skilled labor during mixing. If your mixing quality is not good, you cannot achieve the high strength concrete. Placing and covering of concrete is also most important. This is important for superior quality of structure. If not, concrete will face poor strength, lack of durability, performance issues. All these things will be the problem if you don't have skilled labor, if you are not providing proper mixing, if placing or covering is not good. So you will have to face the poor strength, you will have to face the low durability and lack of durability, and you will also have the performance issues of the concrete. These were the 8 limitations of concrete. Now let's talk about the structural loads. There are different types of structural loads. The types of loads acting on structure for buildings and other structure can be broadly classified in 3 broad categories. The one is called vertical loads, horizontal loads, longitudinal loads. You can see these are the vertical loads and these are the horizontal loads. Longitudinal loads are not mentioned in a building structure. Longitudinal loads are applied, you can see longitudinal loads are applied in bridges and girders. The vertical load consists of dead load, live load and impact load. These are the vertical loads, and horizontal loads are comprises of wind load and earthquake load. These are horizontal loads, and longitudinal loads are usually the tractive and braking forces are considered in special case of design of bridges and girders. Do you know what is girder? Girder is basically a long beam. Girder is a long or bigger beam. Okay. The most important topic, that is importance of codes and clauses. What is basically code and what are the clauses? Codes are the standards of designing, as there are few standards available for guidelines of concreting or building construction. So the similar standards are available for designing. And a construction of building, 2 major factors considered. The one factor that is safety and another factor is economy. If the loads are adjudged and taken higher, then economy is affected. If loads are taken higher, economy will be affected. And if economy is considered, loads are taken lesser, then safety will be compromised. So we need to take both the things together. We need to consider both the things together. We have to take care of safety and we have to take care of economy. So the estimation of various loads acting is to calculate precisely Indian standard. These are the different codes. Indian Standard Code, PBC Pakistan Building Code, UBC Uniform Building Code, ASC American Standard Code, and these are the codes which provides minimum design loads for building and other structures. Even for China, CBC China Building Code is published in 2002. CBC is also a document available which Chinese are using and they are designing. When Chinese students, Chinese teachers and all over the China, when they are designing any project, they have to follow the guidelines which is available in this standard CBC 2002. Specifies many various design loads for buildings and structures. We will also use these different codes in our next semester, concrete structure design, when we are designing the building by the 4-story building for anti-seismic. For anti-seismic building will be designed as a 4-story, and that at that time we will use this code, Uniform Building Code. These are the different types of loads acting in a building: dead load, imposed load, wind loads, snow loads, earthquake loads, and special loads. The most important slide, this is your assignment number 1, and you have to submit this assignment on 22 September. Dear student, please read it. This is your assignment number 1, and you have to submit this assignment on 22 September. If you cannot submit on 22 September, after 22 September, I will not accept any assignment. Okay, it is quite simple assignment. Let me explain a little. It has 3 parts. The first part is define and explain all the load types acting on a structure. Which type of loads acting on a structure? You have to explain, you have to define the load types, and then you have to provide different examples and tabulated values of the materials, means of the different loads. For example, you have decided to provide a dead load of the building. Then what will be the value of dead load of the building? This is just an example. And which things are to be counted in dead load? If I am standing in a building, my load will be which type of load on a building? If I am standing in a building, my load will be which type? So I am moving, so my load will be considered as live load. So you have to provide different types of loads, you have to define them, and you have to give me the example of each different type of load and their tabulated value. You need to create a table of different types of loads and identify the strength reduction factor of such loads. You have to identify the strength reduction factor of such loads. For example, for beams, column, slab, what will be the strength reduction factor? So you need to provide strength reduction factor of such type of loads for different members. And this is just for your guideline. This is the guideline of the Assignment should not match with your co-fellows. If your assignment number 1 is matched with your co-fellows, then I will deduct both of your marks, and should be written in Microsoft Word. You have to write your assignment in Microsoft Word, and only printed assignment will be accepted. You cannot use this. Okay. After due date, no candidate will be entertained. Your assignment should not be matched with the co-fellow and should be written in Microsoft Word, and after due date, no candidate will be entertained. Yes, dear students, do you have any question regarding assignment? Did you understand what type of assignment it is? You have to write this assignment on 1 or 2 pages. It is quite simple, short assignment, and this assignment will have 5% marks of your total marks. And I will provide you my email. I am sending you my email. You have to send me your assignment on my email address. You can check your WeChat group. I have sent you the email. You have to send me your assignment on this email before 22 September. Okay. After 22 September, I will not accept any assignment. Clear? Any question? Mr. Alex? Bruce Wayne, Charlie, Bell, do you have any question?
No, I don't have any question.
No.
Me too. I know. I have no question.
Okay.
No.
Yes, Noctis, do you have any question? The call will be disconnected after 1 or 2 minutes, and you have to join it again. Till now, do you have any question regarding this assignment? It has 3 parts: define and explain all the load types acting on a structure, and you have to provide me the different examples and tabulated values of the materials which are used for those loads, and identify the strength reduction factor of such type of loads for different structural members. Okay. Clear? If you study my lecture, you don't need to go for internet research. Just study my lecture, you will find the answer of this assignment. Clear? Just study my lecture. When you study my lecture, you don't need to move for the internet research. You can give me the answer by just studying my lecture. The call is going to be disconnected. Please join it again within 5 minutes, okay? And then we will finish up this lecture.